Hi, my name is Willem Larson, and this is the Science of Forensic Tracking. A tracker is someone who follows the footprints and sign of a subject, whether human or animal, and pulls information about that subject from those tracks and eventually catches up with them, whether for law enforcement, search and rescue, wildlife conservation, or other reasons. Trackers can tell you an immense amount of information about who made those tracks. Certainly speed, direction of travel, sometimes whether they were male or female, they're human beings, well, what kind of loads they were carrying, backpacks. A certain few trackers, however, have an even more refined ability to pull an amount of information that almost defies belief from those tracks. Information about hunger and thirst, and more precisely what the subject's mood was, where exactly they were looking, injuries, health, disease, thoughts, intentions to move left or right, not just the actual turning in the steps. Some of these things defy belief, and many trackers themselves would express skepticism at these capacities. However, in this presentation, my goal is to provide the groundwork for a scientific theory base to make this elite level of tracking more accessible, more learnable, to make more trackers and the trackers we already have, open them up to higher levels of skill. So we talked about science, and that brings us to the constructal law. In 1996, Adrian Bejan, professor at Duke University, discovered the constructal law. It is a new first principle of physics. Just like we know that energy moves from areas of high concentration to low concentration, boulders run downhill, no one had ever asked, but how does it get there? Straight lines, randomly? Well, Adrian Bejan set out to answer this question, and his answer is in flow systems. Flow systems self-organize to improve the flows, entering them, moving within them, and leaving them. Every flow system is a fingerprint, and thus unique. Just like we have the saying, every snowflake is unique. No two flow systems are exactly alike. Snowflakes themselves are flow systems of heat moving outward from a drop of water that then turns into a crystal. Now, why are flow systems unique? Well, it's the uniqueness of local conditions at the time of creation. You'll never step in the same river twice. You'll never step in the same puff of air twice. This goes to the world of complexity and chaos theory, where differences that are small in initial conditions in one situation and the next can create radically different results. Common patterns of flow systems that repeat over and over, you'll recognize right away. Branching forces that you see in trees and rivers, and wave forces you see when you drop a rock in a pond, you see in a river flowing downstream. Other ways of thinking about this is turbulence, the urge to spin off, to eddy, to branch, to fracture, and laminar movement, the urge toward smooth parallel movement. Now, there is this tension between sameness of the patterns of flow systems and uniqueness of any one particular flow system. They are same in the sense that I can drop a rock in a pond. It'll create a splash and then outward concentric rings. And I can look at a windshield, throw a rock at it, and it'll create a center of impact with ripples moving out of fractures. So you have the same kind of pattern there, but each is unique to their context. You wouldn't confuse one for the other. Forensic professionals do a lot with this in their field, especially with blood spatter analysis, where you can tell the precise angle at which a blood drop impacted on a surface, whether 90 degrees, 45 degrees, 20 degrees. Each degree of impact will look very different. So train yourself to see flows, not things. To see things as flow fossils, freeze frames in time of what energy moving through that area created. So this was part one of a series, and part two, we'll be talking focusing more on track lines and footprints and what flow systems mean for them.